Hello, Professor. My name is Naiba Shabanova, and in this video, I am going to walk through the Lab 10 of the Unix 511. In this lab, we are working with three client processes that communicate with each other using shared memory. To make sure only one client access to shared memory at a time, we use the semaphore for the synchronization. So the main goal of this lab is to implement proper synchronization between client 1, client 2, and client 3 using the POSIX synchrones and system V shared memory. Each client checks if there is a message in shared memory addressed to it. If the message destination client number matches the current client's number, it reads the message, prints it out, and sends a new message to another client. This is done in the synchronous way so that only one client accesses the shared memory at any given time. There are four main code files in this project, client.h, which I will show you, the header file with the constants and the memory structure, client1 CPP, source code for client 1, client 2 CPP, source code for client 2, client 3 .cpp, source code for client 3. In client H, we define a structure named memory that represents the shared memory. Let me show you. I hope it's here. Oh, okay. I opened. Let me open it. As you see, here is my all clients. Let me open the client.h. Yes. So as you see, we can see here the memory name and so what is it? So memory that represents the shared memory block. It contains the integer package number, source client number, the destination client number, and the message string buffer. All clients use the structure to exchange message in a controlled and safe manner. So let's go to the CPP files, which I almost opened. And there are three CPP files normally. Let me open a CPP file from here. Yeah, as you see here, we have the same thing as you. I use the same structure, the intercept control C for the controller shutdown, generate the key here, and create or get the shared memory. So his get and attack the painter to the shared memory. And also we have here in initialize the name. Semaphore can be used between process. So yeah, it's a CPP client 1. Let's go to the second one. Yeah, it's here. The same thing as you see, again, the control S, control the shutdown, generate a key here, generate, create or get shared. It's the same thing as all the things. So again, generate key, create or get the shared memory ID, initialize the name, and also we have here the synchronize the process with Semaphores, send a message to client 1 or 2, send a message to client. So yeah, let's go to the Ubuntu. But before going the Ubuntu, I want to explain that to ensure the synchronization, we use a name semaphore. Each client performs the same wait before the access in the shared memory and same post after it's done. This ensures that only one client is working with the shared memory at any given time. Client 3 is a special because it's a response for starting the communication. When it runs, it's initialized the shared memory and Semaphore writes the first message to share memory and calls the Semaphores to allow other clients to begin reading and responding. Clients 1 and clients 2 wait for clients 3 to make the first Semaphore call so they can start processing message. So let's dive to Ubuntu. Yeah, here I almost run it. As you see, my lab 10 is here. So I'm going to the CD lab 10 ls to see what is there. And the mic clean. I just wanted to again to run it. So again, make all used and all the IP treat, as you see, client 1, client 2, and client 3. And to access for them, I use the cmod start.c. So again, dot slash start dot sh, and after client 1 and client 2 is waiting. So yeah, has received. So client 1 has received a message from client 3. This message, as you see, client 3, client 1, client 2, it's going, and client 2, client 3, and client 1 done. So it means that my Ubuntu is working perfectly. As you see in the terminal, each client waits for its turn. When it's received a message, it prints the sum. Like client 2 has received a message from client 1. So this is a message 3 from the client 1. So after reading the message, the client send a response to the either two clients. So yeah, in summary, in this lab, we successfully, as you say, used the named Semaphores for the synchronization, created and attacked the shared memory, and allowed the three client process to exchange message in coordinated manner. At this lab, yeah, I learned more, and I hope you will like, Professor. I did my best. Um, yeah. Thank you, Professor. See you later. Bye.